In today's lecture, we start chapter number 6, Superposition of Waves. Let's see the introduction of the wave. So we already familiar with different kinds of the wave, such as water wave, then sound wave, light wave, mechanical wave, etc. Electromagnetic wave. But basically the wave is classified into two broad classes. The first one is mechanical wave and second one is electromagnetic wave. Let I tell you example of mechanical wave. Example of mechanical wave is sound. Sound is the example. Example of electromagnetic wave is sunlight, X-ray, gamma rays, UV rays. These are the example of electromagnetic wave. So mechanical wave means sound. You know that sound require medium for their propagation. We cannot talk in vacuum. So the wave which require medium, these waves are means coming under the mechanical wave. Electromagnetic wave, they do not require medium. Electromagnetic wave do not require medium. You know that sunlight is traveling from sun to earth, so it come through vacuum. So here you remember this sunlight does not require medium. So sunlight is electromagnetic wave. Now after that, this mechanical wave classified into longitudinal wave and transverse. So basically sound is a longitudinal wave. Transverse wave is a matter wave or the wave which is set up in a rope when we when we tie a rope to one end and we move it up and down, then rope a wave produced in a rope is a transverse wave or water wave. So water wave is a having a transverse uh, look. Then electromagnetic waves, sunlight, microwave, infrared rays, X-ray, UV rays, radio waves. These are the example of electromagnetic wave. In this chapter, basically we will study mechanical wave only. We are not dealing with electromagnetic, only mechanical wave. As well as we learn reflection of the wave, mechanical wave, principle of superposition of waves, various phenomena like stationary wave, beat, and their applications. Now let me start the detail of this chapter. The first one is progressive. Now what is progressive? So the name suggests everything about it. Progressive means which is in progress. That wave is called as progressive wave. So in simple word, we can say that progress means which is traveling continuously. The wave which traveling continuously without any damping, obstruction is the progressive wave. So you can see here the definition of the progressive wave or information. A wave in which disturbance produced in a medium travel in a direction continuously, in a particular direction continuously, without any damping, obstruction from one particle to another particle is the progressive wave. It is also called as traveling wave. The example is sound wave. Properties of progressive wave. The first property is each particle in a medium execute same type of vibration. So when wave is traveling in a medium, so let I draw one diagram here. If it is a traveling in a medium, then here these wave particles of medium execute same type of vibration here. So here particles are moving upward direction. Here they are moving downward. So here again upward. So all the particles of medium vibrate about their mean position. In the same particle, after some time, it start vibrating in downward direction also. Means they are performing oscillatory motion. All vibrating particles of medium have same amplitude, period, and frequency. So remember, so all the particles having same amplitude. Now someone can say that, sir, this is particle and this is reached to up to this distance only. But here, so at this time, you can see it is moving up to this only. But as wave progresses, this particle can reach its maximum distance, and that distance is the amplitude. So it has all the particle have same amplitude, period, and frequency. Next one is the phase. Changes from one particle to another particle. Phase means state of vibration. The state of vibration for every particle is different, and state of vibration is called as phase. So phase is different for different particle. You can see here, so this particle and the neighboring particle having a different state of vibration. Now when we are going in another part, so this particle and this particle may have the same state of vibration, but in this portion, so nearer particle, they are having a different state of vibration. No particle remain permanently at rest. So not a single particle is at rest. All the particles are performing oscillatory motion. They are oscillating about mean position. The particle attain maximum velocity when they pass through their mean position. In oscillation chapter, we already learned maximum velocity is at mean position. So here also the particle is performing oscillatory motion. The particle attain maximum velocity when they pass through their mean position. Next one is, during the propagation of wave, energy is transferred. When wave is propagating from one point to another point, energy is transferred. Means this wave transfer energy from one point to another point. But here, it transfer energy, but there is no transfer of matter, that you remember. The wave is not transferring matter. Next is, wave propagate through medium with a certain velocity, and that velocity depends on properties of medium. It means that in every medium, a wave having a different velocity, and that velocity depends on the property of medium, such as elasticity of that medium. Progressive wave are of two types: transverse progressive wave and longitudinal progressive wave. So we already have idea about what is transverse and what is longitudinal. In 11th standard, we already covered what is transverse wave and what is longitudinal. Transverse wave means the wave in which particles of medium vibrate perpendicular to the direction of propagation. That is the transverse. Longitudinal means particles of medium vibrate parallel to direction of propagation. Is the longitudinal. Now here, both transverse as well as longitudinal mechanical wave can propagate through solid, but longitudinal wave can propagate through. Now next article is reflection of wave. So let me learn reflection of transverse wave. You know that wave is a transverse and longitudinal wave. So reflection of transverse wave. Now let me learn two cases under that. Reflection from denser medium. Denser means fixed solid medium. And the second case we have to learn reflection from this rare medium. You can see here diagram. So this is a denser medium. So when this wave start traveling towards this side of the denser medium, it incident on the boundary of denser medium, and then after reflection, here this is a crest. So this part is crest. After reflection, we get trough. You can see here diagram. So this crest, after reflection, we get trough. Means here, when transverse wave is reflected from denser medium, crest is reflected by trough. Now here we discuss about in detail about what happened exactly during the reflection. So here two velocities are there. When wave is traveling, so two velocities. Wave velocity is the first velocity and second one is the particle velocity. Wave velocity. Now you can see here this is the direction of wave velocity. And particle velocity I can show it by arrow. So this is a particle velocity. So this is a particle velocity. Means particles are here vibrating in upward direction. So this is the direction of particle velocity. Now after reflection, so this is a wave velocity and the particle velocity is this. Now you can see here the wave velocity is initially towards right side, after reflection towards left side. Means wave velocity reverse. So here the sentence is written wave velocity gets reverse. Now second one is particle velocity. If we see this portion here, so this portion and this portion. So here, before reflection, particle velocity is upward. After reflection, it is downward. So particle velocity is also reversed. So here the statement is written particle velocity and wave velocity both are reversed. Now let I explain here phase. Now we require the concept phase. Phase means angle between particle velocities. Angle between particle velocity. Take a direction of the particle velocity. So here initially before reflection particle velocity upward, after reflection it is downward. So this angle is pi, or we can write 180 degree. So this is phase. So we can say here during a reflection from denser medium, phase is changed by 180 degree or pi radian. So crest is reflected as a trough and trough as a crest. Phase change is pi radian or 180 degree. Reflection of transverse wave from rare medium. Rare medium means the medium whose density is less. Now you can see here picture. So here this is a rope and this is fixed here to support by a ring. So here some gap is produced and that gap acts as a rare medium. Now when crest is incident here on this rare medium, we get crest only. So this is a wave velocity. Wave velocity after reflection. You can see here it is reverse. But particle velocity. Now here the particle velocity is in upward direction. After reflection also it is upward direction. Particle velocity not change. Means this is a particle and wave velocity same. So here obviously phase change is 0 degree. Or we can say that both are in same phase. Incident wave and reflected wave. Both are in same phase when they are reflected from rare medium. In denser medium, phase change is pi or 180 degree, or we can say that the phase is opposite. But here phase change is zero. It means that reflected and incident, both the waves are having same phase. Means phase change is zero or phase difference is zero. If they are same, means difference is zero. You can see here. Wave velocity get reverse, but particle velocity does not reverse. This is a conclusion. Crest reflected as crest. Crest is as crest and trough as a trough. There is no phase change. So phase change is equal to 0 degree or 0 radian, you can say. Now next one is reflection of longitudinal wave. Now when we are talking about longitudinal wave, in longitudinal wave, compression and rarefactions are coming. Again we have to learn two cases. Reflection from denser medium and reflection from rare medium. So case number one, reflection of longitudinal wave from denser medium. You can see this diagram here. So these particles are closer, so this is a compression. The particles of medium are well separated, this is a rarefaction. So C for compression and R for rarefaction. Okay. So this is the denser medium, means a wall. When the wave, longitudinal wave, incident on this rigid wall, it reflects. So this is the incident wave velocity and this is a reflected wave velocity. So wave velocity is reverse. But the particle velocity, if when we are talking about the particle velocity, let I show you particle velocity here. So initially the particle velocity is in this direction. After reflection, the particle velocity is this. Because you know that in longitudinal wave, the direction of propagation and direction of vibration, both are parallel. Now here we can say that particle velocity and wave velocity, both are reversed. So initially particle velocity is in this direction, after reflection it is in this direction. So angle between both the particle velocity is 180 degree or pi radian. So phase change is here pi radian. So conclusion is same, both the velocities are get reversed. Wave velocity as well as particle velocity. Second one is here, compression get reflected as a compression. In previous one, when we are talking about denser medium, crest is reflected by trough. But here we are talking about denser medium in case of longitudinal, compression is reflected by compression. And phase change is pi radian. Phase change pi radian. Case number two, reflection of a longitudinal wave from rare medium. You can see diagram here. This is the incident wave velocity direction. This is a reflected wave velocity. So wave velocity is reverse after reflection. Now, so this is a rarefaction. This is a compression. Means rarefaction reflected as a compression, and this is a rare medium. When wave longitudinal wave reflected from rare medium. Now we discuss about the direction of vibration of particle. Now here, if the particles are vibrated in this direction, then after reflection, this compression also having a particle vibration in the same direction. So particle velocity is not reversed. Particle velocity remains same. So phase change is zero here. So the conclusions are particle velocity does not reverse, wave velocity is reversed. Second one, compression reflect as a rarefaction and vice versa, means rarefaction as a compression. phase change. No phase change means phase change is zero. So let me learn now the next article, and it is superposition of wave. So you can see here two diagrams. This is the first and this is second. So when one wave superimpose on another wave, then we get a resultant wave. So this is a resultant wave. Okay. Now let I explain here. So when two or more, so I consider two, but maybe two or more waves traveling through a medium pass through common point or arrive at a common point. Each wave produces its own displacement. Now let me talk about the displacement of the wave. So this is the first wave, it having its own displacement, its amplitude, it is A1. The second wave and its displacement is A2. At that point, independent of presence of other waves. And the resultant displacement at that point, when they superimpose with each other, resultant displacement at that point is equal to vector sum. This word is very important. Vector sum of displacement of their individual displacements. Now here, so this is a resultant wave. So this is a displacement of the resultant wave. So here this displacement is equal to A1 plus A2, because the displacement of first wave is A1, second is A2. So here for the resultant one is A1 plus A2. Vector sum. So why this A1 plus A2? Because vector sum, here this displacement is upward, here it is upward. So they are added. So A1 plus A2. But in the second case, see the second case. So this displacement is upward direction, it is A1. So here it is downward direction and it is A1. So here resultant displacement is A1 minus A2. And if A1 and A2 is same, then one wave cancel another wave and no wave. So here no resultant wave if both the amplitudes are same. So here in this case, if both the amplitudes